Welcome to the world of entity relationship diagrams, or ERDs. Let's explore the building blocks. First, we have the entity. An entity is a real-world object. Think a person, car, or book. Next, the attribute. An attribute is a property of an entity, like a name, color, or price. And finally, the relationship. A relationship shows how entities are associated with each other. These three components are the foundation of every ERD. Now, let's take a closer look at attributes. We'll describe a student entity with different types. The primary key, which is always underlined, uniquely identifies each student. No two students can have the same one. A simple attribute holds a single atomic value, like a name. A multivalued attribute, shown with a double oval, can hold multiple values. For instance, a student might have several phone numbers. And a derived attribute, shown with a dashed line, is a value that can be calculated from another attribute, like calculating age from a birth date. Relationships have different degrees depending on how many entities they connect. A Unori degree is when an entity has a relationship with itself. For example, an employee might manage other employees. Next is the most common type, the binary degree. This is a relationship that connects two different entities, like a student who enrolls in a course. Cardinality defines the rules of the relationship, specifically how many instances of each entity can be involved. In classic Chen notation, we use numbers and letters. Here, the 1 and n show a one-to-many relationship. One professor can teach many classes. Another popular way to show this is with crow's foot notation. The three-pronged foot on the line also indicates many. It's often easier to read at a glance. Sometimes one entity's existence depends entirely on another. This creates dominant and subordinate roles. The apartment here is a weak or subordinate entity. It's shown with a double border because it cannot exist without its dominant entity, the building. The double bordered relationship is called an identifying relationship, as it helps identify the weak entity. This setup also implies total participation. An apartment must belong to a building. This is a critical rule for maintaining data integrity. Let's put it all together with a simple university model. We have three entities: professor, course, and student. A professor teaches a course. This is a one-to-many relationship. A student enrolls in a course. This is a many-to-many relationship. And finally, each entity is described by its attributes. When you put it all together, ERDs serve as the essential first step, the blueprint for designing a logical, efficient, and well-structured database. From blueprint to reality, ERDs guide the entire database creation process